You're listening to Across the Pondcast. Cybersecurity rants and war stories from both sides of the Atlantic.
Hello and welcome to Across the Pondcast, a show where we talk and occasionally rant about cybersecurity topics with perspectives from both sides of the Atlantic. I am Tib3rius. I'm joined as always by my wonderful co-host, Mr. Andy Swift. Andy, how are you doing?
I'm fabulous, thank you. In a very good mood. I haven't long got back from B-Sides London, so, fun.
I'll have to go sometime. I've never been to B-Sides London. I've been to plenty of B-Sides in the US.
Yeah, that's it. You're coming to London. I'll sort this out next year. Perfect. I'm going to buy you tickets. You're coming.
Deal.
Yes. There you go, London.
Well, today's episode is Hack Smarter, Not Harder, Why Custom Tools Matter. We're going to be discussing the importance of being able to create custom tools, especially in the pen testing field, and talk about real-world examples that we've made. But before we start, this show is made possible thanks to our sponsors, so let's take a moment to tell you who is sponsoring today's episode. When it comes to web application security testing, one size never fits all, and that's where Burp Suite's extensibility really shines. Burp Suite gives you the tools to customize, enhance, and extend its capabilities, so it works exactly how you need it to. Take BAMDAs, for example. They let you create precise, reusable power-ups that integrate seamlessly into Burp's core tools. Or B-Checks, a quick and easy way to design custom scan checks tailored to uncover vulnerabilities specific to your application. Plus, with extensions and BAPs, you can code entirely new tools and functionalities, making Burp Suite the ultimate Swiss Army knife for web security testing. Whether you're an individual pen tester looking for efficiency or part of a team tackling complex enterprise apps, Burp Suite adapts to your objectives. Test smarter, not harder with Burp Suite's powerful extensibility. Learn more at portswigger.net and take your testing to the next level. How do we want to approach this one?
Right, I think we start way back when, as we usually do, with Heartbleed. Heartbleed. It was a sunny afternoon in London. Actually, no, I'm lying already. It was a morning. So it was a morning. We were doing, as usual, we can't really tell you who or the types of organisation it was. Very important organisation. And we're doing an internal pen test for them. We both turned up. We had gone for our usual morning coffee. We always had morning coffee before going to an internal test. We once forgot to pay for our morning coffee. And we then realised about 12 o'clock into the day, and we went back and paid for the coffee because we felt so guilty. I remember the lady was on the counter at the time. She's like, people don't usually come back and pay. This is London.
I mean, they were happy we did.
Yeah, it meant we can go back again, which is also good. But we had our morning coffee. We had turned up to this internal pen test, and this was a client that had been a client of ours for a few years now, and it was for a good few years afterwards, I suppose. It's one of those clients where you start off with a terrible pen test, and you gradually, with them, you get better and better. Each set of results you do, they come back cleaner and cleaner. They start to tidy up their network bit by bit, and we got to that nice stage where, kind of suspecting not to find much on their network, and then you turned up, didn't you?
Well, it was more that the night before Heartbleed had happened, right?
And you turned up.
And Heartbleed was an interesting vulnerability because it wasn't in SSL, it was in OpenSSL specifically. And it was a weird feature of the SSL spec called heartbeats. It's kind of just a way of, I believe, just keeping the connection alive. So you would, but the way it was done was weird. Like, so the idea was you would send this heartbeat, which could contain a custom message. I honestly, to this day, don't really know why it was custom. And then the idea was if the server was still okay with the connection, it would send back that message, which is, I guess, fine. like ideally it shouldn't have. They should have done like a ping pong thing. I feel like if they'd done that, none of this would have happened. But for whatever reason, they made it a custom message, and the way it worked was you would tell the server how long your message was, and then the server would respond in kind with the same message. The issue was you could like send 3 bytes in your heartbeat message and say that you were sending 3,000. And then the server just reads 3,000 bytes from memory. So it starts with your message and then just random portions of memory, which is the whole bleed thing. So basically you're able to get a server to bleed memory. It was a very cool name. And yeah, the night before, I think it had been discovered, there were a bunch of concept codes available, and kind of just on site that day, we weren't finding really anything, right? It was their environment was pretty locked down, if I remember correctly.
Yeah, very, very locked down. We used to usually have that joke of you can't go for lunch until you get domain admin, which is lovely until you come up against a very well configured domain where you can't really get control of it by lunch. And then we got very angry and very hungry. So yeah, it happens occasionally. And this one had been patched to high heaven. The antivirus was literally catching everything we were throwing at it. Even if we did find something, we were really clutching at straws to be able to get anywhere. So yeah, lucky this dropped the night before. It really wasn't it. But like you say, the proof of concepts were there. They were just a bit ropey because it literally happened hours before we arrived. So it was just in that lovely discovery phase where everyone's just kind of going, this is a thing, and then building their own sort of proof of concept tools, and some of them don't really do the whole thing, some of them aren't weaponized yet, so it's that nice entry route into your first sort of exploit creation, if you like, where you're weaponizing something that somebody else has done a bit of a proof of concept where you're improving on it and you're taking it to the next stage. Because the memory that was being leaked, I mean, you can imagine what was in there, right? I mean, literally anything, right? So you could cookies.
Yeah. It could honestly be anything. It depends on the server. But for web servers specifically, it was a big issue because it's happening on... the SSL is being implemented at the server level, the web server level. And so what's generally going to be stored in memory around that area still is requests, responses that the server is in the process of sending or has just sent out. And yeah, that can contain interesting stuff because obviously a web server is not just being used by one person. It's going to be used by multiple people. And so, yeah, you could get cookies, which, can allow you to authenticate as other people. You might even stumble on, if there's a login page, passwords. In an Active Directory environment, you may even, if the actual web application is using some kind of NTLM authentication, then there could be NTLM hashes in there as well. So honestly, just plain terrible. Because it's all unencrypted as well. Because of course it is. It's in memory. You don't need necessarily, or you don't really, on a server, you don't encrypt anything in memory if it's being processed by the application. So yeah.
Yeah, it tends to be where things are not encrypted. But also from the incident response side of it, it didn't really leave a trace, did it? It was one of those vulnerabilities that was within a certain space. It didn't really cause any logs, didn't really cause any alerts. There wasn't really any way of seeing that it had been exploited because you're literally reading memory, but it was returning freely to you and not even logging what it was sending back. So it was a really nice exploit because it left literally no trace of exploitation. So your earliest indicators that something was up was it's going to be elsewhere or further down the attack chain. Because usually in instant response, we want to find that initial entry point. But yeah, this vulnerability.
It was one step down from the TCP level, basically.
Yeah.
Or I guess one step up if you're, depending on how you're looking at the OSI model, I guess. It's at the SSL TLS layer. So that happens before any kind of real application functionality. Technically, SSL and TLS, I think, counts as application layer, but it's happening before any kind of application is doing anything. It's kind of it's at the SSL setup stage as well. Like you could send this. So you don't need to send, or you didn't need, I should say, to send an actual HTTP request to exploit this against a web server. If you were dealing with an email server, you didn't have to send any kind of email packet, right? Like SMTP or POP3 or anything like that. Nothing. So there are going to be no logs, usually, on the actual application that you are attacking.
Right.
There could be at the SSL level, but generally speaking, no, not really. Like, that's realistically not something many logging systems actually log. They probably do now, but back in the day, definitely not. And even if they did, you're just seeing a connection. Like, there really wasn't anything to indicate. I don't think heartbeats were something that would be logged. They were that sort of inconsequential that there's no point.
You don't tend to log things like heartbeats. I mean, it's actually one of those things. It's a keep alive request. I mean, that's what it's there for. They tend not to be important or things you log for diagnostics or anything like that. If you're engineering, so this or any other system, I mean, the level of verbosity to log something like a heartbeat is that's quite a detailed level of logging. You might also argue that that's too much logging to do. I mean, if you're logging things like that, your logs are going to fill up very, very quickly on big networks. So there's a balance to be made there. But yeah, it really played into our hands. Night before this came out, several vulnerable servers on the internal, and then you wrote a rather nifty tool. You wrote it pretty much on the fly, I think, whilst we were sat there. Successful with it.
Yeah.
Domain control, got to go for lunch.
Yeah. I forget how we actually got the domain. It must have been some kind of, it was either a cookie or a password we found. But yeah, the tool was effectively a proof of concept Python. So there was somebody else's proof of concept Python code I found on GitHub that I could read through and understand exactly what they were doing and modify it, give it a bunch of arguments. And then the real nice thing about the code was the detecting of stuff in responses. Because if you're just doing memory dump, like that could be anything. And so what was the nice part about it is literally you could code in, okay, well, I want to, do regex, regular expression checks for certain things I'm expecting to see, and removing anything, removing bad characters, right? Nobody really cares about the null bytes and, other unreadable characters, really. So it was the fact that you could, send the payload as per usual, and then also sort of scour automatically the response for data and do it repeatedly, because what you wanted to do was just keep sending a heartbeat and keep exploiting it, because every time you're going to get some new memory. The other modification I remember was the proof of concept hard coded some cipher suite selection values that some servers just didn't support. And so what I did was I was like, well, technically speaking, you could just tell the server you accept any cipher suite. Like you could just list them all. And so that's what I did. Like, so the exploit listed all of them, and it was like, this is guaranteed to work against absolutely everything. Yeah,
it's that nice thing of taking an exploit, modifying it to your needs, and just making it easier to use. Find the things you need it to find on a quick basis. Weaponizing it basically is what you did, and that's sometimes the nicest way to start developing tools for your purposes. Anything that can regex. I'm pretty sure it was a password in the end. I don't remember us getting a cookie. I'm pretty sure it was a password we actually caught in plain text in memory somewhere. We then used to log onto a server, and then typical kind of Windows domain ownage from there, really, at the time. Yeah. Once you've got an admin account, I mean, that's kind of game over, especially at that time anyway. Nothing really to stop us after that point. So, it was kind of game over. But yeah, really cool tool. And yeah, I remember having to spam memory for it, because that's the other thing when we had those early proof of concepts. You're literally like, yeah, it's returning memory, but there's nothing interesting in here. You literally spam it and spam it and spam it again and again and again. And there's no limit to how many times you can spam it. It wouldn't crash the service or anything. Or if it did, it was very, very rare. So you used to be able to send thousands and thousands of requests, not logged anywhere, no hint. It was quiet as a mouse, the perfect exploit. So yeah, your tool just abused all of those things really, and just put it into one nice little neat tool for us to get our lunch out of.
All the same connection as well, I should note. You didn't have to reconnect. You could just connect once, and then you could send a heartbeat as many times as you wanted. So yeah, that was kind of cool.
It was neat and quite fast. I used your tool years later, actually. I hate telling you this because it must make you feel really smug.
It does.
Yeah, it's still in our GitLab repo, our private one. People still use it to this day when they see Heartbleed because it was a good tool. But yeah, I used it a few years later. Again, it was an application. I managed to rip a load of cookies out of it. Yeah, it turns out just user accounts for the application it was, but managed to escalate from there. So yes, it worked. Thank you.
You're welcome.
It sort of ties neatly into that question though, that popular question about do pen testers need to code?
And my answer has been the same for years, and it's always been no, but it'll make you a better pen tester.
Yeah, there you go.
Like, is it really necessary? Strictly speaking, no. But like, you're going to get crushed by the competition.
Yes,
That's the thing. Especially if you're going for an interview, and if you have a GitHub repo that's full of like random little scripts that you've coded, and the person you're, for lack of a better word, competing against to get the job does not, that's really good for you.
coming at it from a slightly different angle as well. My view on that's a firm yes, should be able to code, actually. Somewhat harsher than yours, which is surprising. Mine's a firm yes for it. I think people do need to know how to code if you are going to pen test. And because there's always this chance you're going to download something one day and you don't know what it does. If you can't code and you can't read the tools you're downloading or the open source proof of concepts you're downloading, personally, I don't see how on earth you're going to be able to trust those tools, not knowing exactly what they do. And from the consumer point of view, do I want a pen tester in my network who can run tools but doesn't know what the tools do that he's running? My answer is probably no again. But I see your point. Do you need to know exactly how to code and write your own tools from the get-go, from the junior position? No, but you are looking at entry level. And I'd suggest that after you spent a few years at that sort of junior level, learn to code, start modifying your own proof of concept stuff like you did with Heartbleed and things like that. Start making them your own, because that's a nice proving ground. It's a nice introduction both into exploit development and into just coding in general. And you start to build up an appreciation of what should and shouldn't be in a tool, should and shouldn't be in a proof of concept. And then you'll start to build up that knowledge of, hey, this tool I've just downloaded from GitHub might not be all it seems. I've seen that a few times. I've seen cybersecurity people even posting on X, stuff like that, reposting things like, look at this cool new tool. It's like, yeah, that's actually not what you think it is. So it is literally everywhere. So yeah, it's a firm yes from me, I think. And it helps you in the long term. That's not to say you can't get into the industry without knowing how to code. I famously didn't really know how to code too much when I came here, as you will attest to, I'm sure. Yes. But you taught me a lot about programming.
In my defense, right, the question was, do you need to know how to code to be a pen tester? And I did say strictly speaking. So yeah, like, do I want my pen testers to be able to code? Absolutely, 100%.
Yes.
But strictly speaking, you can do pen testing without knowing how to code. You will run into a position where it will make you a bad pen tester because you won't be able to exploit things that you could otherwise exploit or react to interesting situations, which I'm sure we'll cover this episode.
Take the example you've just given, the Heartbleed example. If you hadn't been able to do that, we probably would have walked away going, there's this new thing called Heartbleed, by the way. You might be vulnerable to it. But we wouldn't have never been able to prove the depth of it, the effectiveness of it, and all that sort of stuff. It's not always about the tool, it's about the effect it can have on your clients. And being able to give someone that early heads up on the effects and how it would directly affect their network, that's a really powerful statement to be able to make. So it's absolutely invaluable. But yes, my coding prowess when I first started as a junior was something to behold. Yeah, we'll start from somewhere. Cowpat was one of my first tools. You remember that? Brilliant name.
I do.
I can't remember what it stands for, which is great. Something online word something.
Password analysis tool, I think.
Yeah, that was probably it. It was a password analysis tool.
God, what did I feel like the cow was just because you like cows.
It wasn't
like I feel like we've established that. If anyone's watched my interview with Andy on YouTube, yeah, Andy likes cows.
Yeah, I really do. I really do. If anyone wants to send in pictures of your favourite cows, you're more than welcome. Maybe we'll do an episode on covering cows. Yeah, no, okay. Vetoed. It really was just because there was a running joke on them, and I wanted to work the word cow into the tool I just developed. but it was a password analysis tool, a bit like PyPal was.
It still is.
I don't think I knew about PyPal at the time when I created it, or it came out after. Certainly didn't exist when I started developing it. But yeah, it was kind of an early version of what that went on to do, which was it was interesting at the time. But yeah, it was one of the early first scripts that I developed was like, we continuously keep owning these domains, these Windows domains. We have lots of passwords in them. Wouldn't it be fun to also give the client some analysis and some context on how many bad passwords there are, how many recurring ones, how many ones use days of a week, how many are pending numbers, letters to the end, how many are using combinations and characters, and just putting them, what position they're putting them in commonly. Are they sticking just an exclamation mark at the end? Yeah, the usual. So it's just an analysis tool like that, and it spat out a nice little PDF with lots of these different statistics on them. And that's all it really did. And admittedly, the 0.01 version of it that you saw when you came in probably had a few too many while loops in it that were all nested together in a horrible spider's web of doom. And
yeah. Should we explain the while loops of Andy Swift?
I think we might be out of time.
I can't remember what it was, but one time you showed me some code that was taking forever to run, and it was just because you had like 4 while loops and they were all embedded in each other, and there was no reason for them. You'd started writing one and then I guess forgot that you'd written one and just started another one, and then four down. It's like, well, that's why.
Yeah, I'm going to turn to drink. I've got some whiskey here. This whiskey's called Bee Juice, by the way. Bee Juice. I think it's from Jeremy Clarkson's farm.
Oh, that makes sense. Fair enough.
Might have some of that later, or now, drown my sorrows. We all start somewhere, right, with this coding thing. And yeah, I was doing that, and yeah, you to be fair to you, you taught me a lot about coding and good practices and how not to nest so many while loops. But it'll start somewhere, and that was one of my first tools, and it was something that was helpful. It's something that we could put into reports and add context, because that's the other thing. With a lot of these custom tools need to do, especially if you're in sort of the pen testing or red teaming sort of world. If you're writing custom tools, custom exploits and things, something nice to keep in mind is that the added context that those tools can give to your reports or give to the clients at the end of it is a really valuable thing. And if you can do that again is going to put you on that sort of that next level above. If you're just running somebody else's scripts, you don't really know what they do, you just know the result of it is you pwned a network. That's great. It's very sort of level limited. It's sort of limiting yourself to a certain plateau. But if you've got your own custom tools that can do more in-depth analysis of the stuff that comes after the exploitation, tell the clients more about their network, more about their setup, more of what's good and what's bad, tell them more about the effects that XYZ can have. And that's what your tool with Heartbleed did, and that's what the password analysis tool both did, is it gives you the opportunity to go, yeah, we've exploited this thing, but this is the result of exploiting that thing. This is how deep it goes. And this is how quickly something can spread through your network. This is the effect an attacker could have from this position. And those conversations really with clients are when it gets interesting. It's not so much that we've reported and exploited this thing. It's more the, so what? What happened afterwards? What comes next? It's all those sorts of conversations that can really take your reports from sort of beginner level right the way to like a super advanced, good in-depth report. Context is everything, baby. Yeah. But I don't think I've ever stopped developing tools really since then for my own sort of gain and benefit. You've moved into the world of burp extensions, haven't you? Really?
Yes.
You've done a few of them.
I think I remember why I got into it. It was because it was when I was a junior pen tester doing a web app engagement, and there was a specific bug that I don't think Burp Scanner really detected, or if it did, it didn't do it that well at the time. And it was more the ones you had to do manually. And I didn't do a good job. And it was like one where the customer came back later and said, hey, one of our maybe one of the QA people found it. Why didn't you? It wasn't like I hadn't found other stuff. I'm sure I'd found like XSS or something. But yeah, so it was at that point, it was like, nobody was mad. Like, this happens. People miss stuff, especially if you're a junior, you're going to miss stuff. Sorry to any junior pen testers or wannabe junior pen testers out there. You're going to miss stuff, and it's going to get found later on, and it's fine. It really is. It's okay. But I was like, oh, damn. Like, I was annoyed at myself for missing it. And I was thinking, well, how can I make sure I don't miss this again? I'm going to create a tool that basically automates it. And so I started reading about how to create burp extensions, and at the time, and I guess still to this day technically, but thankfully the burp extension's main language is Java, because burp is coded in Java. And so, yeah, I knew how to write Java because I was a computer science graduate. And I don't know if it's true today, but if you did computer science degrees back in the 2000s, Java was what you were taught, at least Java. Right? So I knew Java, and so I could I could create a burp extension. And I've created a fair few now. Some of them are more public than others. Copier is my latest one, which just helps pen testers copy requests into reports. But I've got, a few others that are mostly private, mainly because I came across a very specific scenario which required an extension. And I think the go-to example for me is there are apps sometimes where there is some kind of JavaScript-based signature generation. So you have a very JavaScript-heavy application that, before sending any request to the server, creates a signature for the request. It just makes testing so much more difficult. And it's not like you can't generate the signature yourself, because it's literally in JavaScript. So if anything, it just delays an attacker for a little bit. But effectively, if the signature doesn't match the rest of the request, then the request gets rejected. And obviously, if you're trying to fuzz an application, you need the signature to match, because you need those values to actually get to the server. So I looked through the JavaScript code, I pulled out the signature generation code, flung it into a quick burp extension, and basically got burp to re-sign every request as the last possible action it did before sending it to the server, after everything has been updated. The last thing it does before it sends it to the server is regenerate the signature. And there was another example I've come across, which is a very weird application. I think I've only come across it once, where every single request required basically a one-time code that was provided by the previous request. And so that's just annoying to test in general. Ordinarily, if you're testing using Burp Suite Scanner, you can test multiple things at the same time. You can send multiple requests. You can get the scanner to do things concurrently. In this application, you couldn't, because literally it was basically it was almost like it was a single threaded. It was like forcing you to be single threaded. Because if you sent a request that had invalid code or no code, it would get rejected. And these are one-time use codes. So basically, you look at the response of the last request, you extract the code, you use it in the next request, and then you repeat. And the extension was a very easy extension to write. It just annoys me that I had to write it, because all I had to do was look at the last response, extract the code, store it in memory, and then when a request is sent, grab that code again, insert it into the request, replace whatever code was currently there, and there. That was it. It's a very, very simple extension, but it's just annoying. However, it meant we could actually do testing, because you can set scanner to be single-threaded. So you can tell the scanner to only scan one request at a time, and that's what we did. But at least it would work. So yeah, those are the ones that sort of really worth learning to code burp extensions, especially if you're a web app tester using Burp Suite, just because you'll come across those examples. And fortunately or unfortunately, whichever way you want to look at it, these days that means using Java, because the Montoya API in Burp 2.x is only Java. And I don't think they have any plans to use like Jython, because Jython is awful. It doesn't support Python 3. I don't think it's been updated very recently either. It's just terrible. Like, Java isn't that bad of a language, in my humble opinion, but other people will obviously object to that.
I'm going to get that printed on a t-shirt for you. I'll just,
What, Java isn't a terrible language?
yeah, I'll just watch people come at you at cons. Yeah. Let's do it. Just send you like slaughter to the lambs. I love all that. A lot of these tools and a lot of these scripts and things, they're born a lot out of necessity, or to enable testing to progress at a certain speed, or because a lot of the time, we covered a little bit of this in our scoping podcast in episode 1. Sometimes you don't have an awful lot of time to learn an entire application and get it working the way you want it to be working for you to be able to test it to destruction. So a lot of the time, a lot of these tools are just purely there to help, to aid, rather than to actually exploit themselves. And those are sometimes the more valuable tools in themselves. They have a big shelf life. Like I said right at the beginning, we're still using certain Heartbleed scripts, our end, which you really like that, don't you? I can tell. But yeah, a lot of them are just born out of necessity. I also reiterate a point you just said as well about you will screw up as a junior, you will miss things. You absolutely will. That's such a powerful point, because and if you do, come let us know, but we'll give you a hug. I don't free hugs for all those that have messed up. But it's one of those things everyone does. We're doing something that is kind of borderline in itself. We're hacking a system, we're getting a computer system of some sort to do something it's not meant to do by default. There is always going to be an area where you will miss something, or something you've written is not quite right, and it will cause something to fall over, or yada yada yada. We've all been there, and anyone that pretends they have not is just lying to you. We've all got these stories kicking around. So yeah, don't be worried. Carry on, keep on doing it. Get over it. Learn from it is probably the best thing to do. Don't repeat the mistakes. But yeah, if there's things you can do, like building a tool to make sure you don't miss certain things in the future, go and do it. Write yourself a cheat sheet. All those sorts of things. So they're all super helpful, and it's sort of learning tools. So just one such tool is things like the mscan script that we wrote for doing a certain job. I've recently put together an updated version of it called... Yes, that's right. It does start with that. It's called which is really catchy. Which
how do you spell it?
MNUST, multi-threaded nmap upscan tool. Anyway,
you've made upscan 2 words for no reason at all there.
There's a reason. There's a very good reason, and that's because if you take that out and make upscan 1 word, it just becomes nut.
Okay. All right.
Maybe I should call it that. Gets more stars on GitHub.
Just take out the M. Just call it nuts.
Just call it nut. I have a feeling there'll be a lot of people that download that expecting it to do something else. Very sad when all it does is scan a network. But this, the revamped version of a tool literally does what the old one does, just in a more modern fashion, in a slightly more intelligent way. And the problem was first brought to us many years ago when you and I were told to do an external test, weren't we, of many /24 networks. And we had to end up scanning a lot of them as quickly as we possibly could, because we only had a limited amount of time to doing it. So doing it as efficiently as possible was something we had to do. So working out which hosts within these vast ranges were actually up and communicating or had any kind of life associated with them was quite important. So again, quite early on, I'm sure there's other things that do it nowadays much faster maybe, but depends how many while loops I put in there. All it would do is scan for top 100 or top 1000, I can't really remember, TCP UDP ports, and it would just list them out. If it found one of them, it would report back and just say, this host is likely up, and it would queue it up for
Yeah.
further scanning, further interaction, further exploitation. So when we've got only a limited time on pen tests, what we want to do is focus our time effectively on those hosts that are going to be very important, rather than just wasting time hitting dead hosts, or running a Nessus scan for like 4 days and just having it time out endlessly. It's quite nice to be able to just use tools like this to just go, these hosts are likely up, they've likely got other stuff on them, it's got these bad ports open on them, there's probably something more to find there, and flag it for further investigation. And that starts to help build your priority stack up when you're doing these external pen tests, because it's rather than just trying to scan everything, hit everything, and then look over it all, what you're doing is creating a priority list and go, this is what I'm going to look at first, this is where I'm going to probably find the most issues, I'll queue that up first, and then I'll come back, do the other stuff later. I'll look over all the dead hosts or hosts that have got things on weird ports after that. So you're focusing your attention on where the most likely areas you're going to find stuff are. And again, it's one of those tools that just helps you prioritize, helps you streamline your workflow a little bit, and point you in the right direction and give it some structure. I'd love every client that you have to come to you and go, I've got infinite budget for you to sit here all year just to scan stuff. But, none of them do. You've got time frames. And finding what you need to find in the quickest amount of time is kind of important a lot of the time. So that was a real nice helper tool for us.
So I actually used a similar technique in a tool that I wrote, and possibly got, in quotes, famous for, auto recon. So auto recon is, for those who don't know, was a tool I wrote mostly for doing the OSCP. It's effectively an enumeration tool. So it will go and scan for ports and services, and then it will spawn other scans for, so the go-to example, if it finds an HTTP server on a host, it's going to launch various things. Like it'll launch Nikto for you. It'll launch Feroxbuster to do some directory busting. It'll run Nmap with lots of HTTP scripts enabled, for example. But what I realized early on, you want, if you're in the OSCP exam, which is notoriously time limited, so you have 24 hours, you don't want to waste any kind of time. And you still also want to scan every single port. So that's 65,000 ports on, at the time, 4 different hosts. And there's an issue with that, which is if you're using Nmap to scan for services, Nmap will report ports that it finds in real time. So it'll say, oh, by the way, port 80 is open. But it won't report what services are running until basically the very end. So if you enable service scanning, it won't actually tell you that port 80 is running an HTTP server until it's finished, which if you're scanning 65,000 ports is really bad, because that can take ages before you even, and you could guess, right? You could say, okay, well, it's port 80, it's HTTP. But what if there's a web server running on port 3289 or something, So the idea I had was, well, I'll definitely need to run a full TCP scan, but I can also just run like a top 1,000 port scan. And the idea being, top 1,000 port scan is going to return quicker than a 65,000 port scan. And so even though you're not scanning all the ports at that point, you've scanned, honestly, 99% of the ports that are going to be up, that are going to have stuff running on them, just because they're the most popular. And so you can actually get away with quickly scanning the most popular ports, then figuring out the services on those, and then you start like actual service-specific scans while your full TCP port scan is still going. And so yes, there's a little duplication of effort there, because you are scanning in your all port scan, you're scanning those 1,000 as well. But it's okay because it works out faster overall. So yeah, that's it. Sometimes in pen testing, it is about time management. And the OSCP exam, I think, honestly, is not a good exam. I don't like the fact that it's 24 hours. It really shouldn't be. For a pen testing exam, it does suck. But the one thing it does teach, I guess, was good, is time management skills, or at least it tests for them. Because, yeah, absolutely. If you want to pass the OSCP, you need to be able to manage your time properly. So many people just run out of time. And, sometimes it is a skill issue in that they just weren't ready because they don't know the exploit or they don't know what they look for. But for a lot of people, I imagine, it is just because they literally ran out of time. They could have passed if they'd manage their time a little bit more effectively. So yeah, I think tools for making pen testing more efficient and more time effective, they're just good to have.
Yeah, I absolutely agree. Time limitation is our biggest problem in the pen testing world, especially where manual pen testing is involved. It's one of the biggest problems, and it's why things like bug bounty programs and things like that are becoming so popular, I guess, isn't it? Amongst other things, just having people out there who can go at something for endlessly for a reward is incredibly attractive. Yeah, pen testing absolutely has its place. Likewise, so does red teaming, and so does bug bounty hunting. They all have a place of making up cybersecurity sort of defenses and your cybersecurity programs. They absolutely do. They all make up part of a puzzle. It just needs to be used in slightly different ways. So it's a nice way to segue into the next section, really. Talking about things like implants and things like that, it's quite an interesting way to go, because it starts off, or my coding journey started off just by making scripts, modifying things, understanding what other people have done, like we've spoken about already, really modifying proof of concept codes and doing your own thing with it. And that's absolutely a great way to go. And then you move into that world of, well, helpful stuff. That's what's going to speed up my testing, what's going to stop me finding stuff. And that's a lovely story as well. I'm still making things like that. If there's new situations that come up all the time and you're like, I could create something that can scan for that, or that can speed up that process in an instant response. And those are really, really helpful as well. And then you move into when you get quite accomplished at programming. We, especially when we're doing things like red teaming engagements, we use things like keyboard implants and stuff like that, or rubber duckies or things like that, which everyone knows from the old Hack 5 kits. But we tend to use things like a little device. Have you heard of DigiSparks? Like the little, about the size of a thumb, like USB sticks. Nice and programmable. You can run the same sort of ducky scripts you can on a rubber ducky, but they're much smaller, much more memory limited, so it forces you to be more efficient in your coding. So old Andy would have been absolutely useless at this. It would have run out of memory space very, very quickly. But it forces you to be very efficient in your methodologies, your ways of doing things. So probably stick a link somewhere for people to go and get them. They're only like $4 as well, I think. Or they used to be.
Damn.
They're super cheap, which is really handy when we're talking about red teaming implants, because the last thing you want to do is leave like your $50 device somewhere in the hope that it gets returned to you one day, or just to burn through like OMG cables. As amazing as OMG cables are, I would be so unhappy if I lost one on site or it just got binned or something like that. So yeah, if you're looking at a fairly specific use case, these little things are really helpful. And yeah, if you can be really efficient with your coding, you can get lots of really interesting things, tools, exploits into very small spaces. These things are great. We've recently done a red teaming engagement where we embedded these literally in keyboards inside implants, because we knew that the client was just getting a shipment of keyboards not long after. Don't know how we got wind of that. We just got wind of it somehow, and they were expecting like a big delivery of new keyboards across the office. So we were like, right, we're going to build some implants. We're going to stick them inside USB cables, and it's going to be great. And all they did was just dial back, download a payload, and then called back to a C2 server somewhere. But yeah, if we didn't learn programming, we wouldn't have been able to get into that. And I feel like that's the kind of area a lot of juniors like to be in these days, because the first interview, the first question I get nowadays for junior roles is, when can I start doing red teaming? When can I get involved in that stuff? And you're like, well... It's a lot of learning, first of all. Can you code? So all those skills go to help you. Speed of finding stuff, being able to code, being able to think on the fly, being able to understand bespoke things that other people might not have seen before or tested before. All of those sorts of things are going to start coming into play when you start doing those kinds of jobs. So it's a big learning path. Everyone wants to get there, though. But yeah, start small. Definitely start somewhere.
Yeah. Has red teaming grown a lot in popularity in the UK recently then?
Popularity's growing. I wouldn't say it's not like you guys. I mean, America. I'm deadly jealous of like the American cybersecurity scene, because you guys are just like, yeehaw, let's go and just do the most deadly tests wherever we can and see what happens. And over here, we're very stereotypically probably also quite reserved about that sort of stuff. Pen testing, we like those, and I tend to talk a lot to clients about. They're starting to come to us a lot with the terminology red teaming and saying, we need to do red teaming. And then you always sit there for like a moment and go, I'm not entirely sure you know what red teaming means. So I'm just going to I'm just going to prod around the topic a little bit and just find out. I just go, this is what red teaming is, and tell them a few things about what you do. And you sort of gauge their reaction. You go, I'm not sure you're quite ready for what we're talking about here. And we introduce topics like scenario testing and things like that, where we basically just do red teaming things with some sort of stabilizers on, basically. Wrap scenarios around them so they know what's coming and all that sort of stuff in a kind of way. It's a bit more aligned with purple teaming testing, I guess. But yeah, it's becoming more popular. It's not really there yet, though. I wish it was, because it's so powerful. But I think people generally lack that kind of global view of cybersecurity. Everyone's very sort of focused, especially in large organizations, of a project, a environment, an application, and that's that project team's responsibility. But a lot of people tend to lack that kind of global, this can affect loads of other things, or a problem here can affect this here, this here, and this here, and start thinking about the organization as a whole rather than just in the tiny little segments that they're responsible for. I think over here we're quite bad about sort of thinking.
Yeah, I mean, going back to how we opened the episode with, do pen testers need to be able to code? However you want to answer that question, I think for sure, if you replace pen tester with red teamer, the answer is definitively yes, unequivocally. Yeah. Like you can't be a red teamer and not know how to write code. Like, it's impossible. There's so many more situations where coding is just absolute requirement for red teaming.
Yeah, absolutely. But well, you've changed my mind slightly on it, Tib3rius, my boy. It's right at the beginning. Everyone's got to come into it somewhere. And I remember there's a chap I bumped into at B-Sides who I hired years ago, a chap called Chris. Shout out to him. We might get him on here one day, if he's brave enough. But he used to be a firefighter many years ago when we recruited him. No tech background. And hands down, I'd say probably one of the best testers I've met over the times. So I hope he's listening to this, because he owes me a box of chocolates now. But yeah, he's wouldn't have come in with any real sort of coding practice at that time, or coding knowledge at that time. And it's like, well, sometimes it's about looking at how people are going to pick up on things over time, their ability to adapt, their ability to take on information. And those early stages, no, it's not necessary to get into the industry. But like you said, it will very much help you progress.
Awesome. Well, thank you so much for listening. I've been Tib3rius. He's been Andy Swift. This has been Across the Pondcast. You can find all of our social media links in the episode description or on acrossthepondcast.net. And of course, we will see you next time.
Bye.
Thanks once again to our sponsor this episode, Portswigger. Explore Burp Suite extensibility and elevate your web security testing at portswigger.net.